Okay, so what we're going to do is we're going to finish our last section in graphing, right? So we're going to look at plotting travel graphs, and we're not really going to learn anything particularly new here. We know about graphs, and we know about making graphs. This is really about reading graphs, and it's a specific type of graph that involves getting from one point to another point. But what we're really talking about is just a graph that measures time and distance.
Is that a travel graph?
That's a travel graph. So it tells you how far you've gone over time. In other words, it gives you a rate or a speed. Okay? Of course. All right, so we're going to look at a few things about them. The first thing I want to make sure that you know is that you can't have a travel graph, or time and distances, without having units. And think about the appropriateness of units. If you're walking somewhere, then you might use what kind of time units? If you're walking to school, does it take you days? No, maybe. Well, but I mean, if walking is your normal route, a normal way to get to school, minutes probably, right? Okay. Now, when you're walking to school, do you think the distance would be measured in miles or kilometers? Kilometers, maybe, but that's pretty far even, right? Probably meters, because otherwise you'd take the bus or get a ride or something like that if it was very far. But what if you were driving from Wellington to Auckland? What kind of units do you think those would be? Miles are probably kilometers for you guys, right? You don't use miles here. And would you measure the time in minutes then? Probably hours, right, to get to there. So make sure you were thinking about times, all right? So what if I was going to sail across the world, or all the way around the world? So you could use nautical miles or kilometers, but you would use days or perhaps even months. Yeah. So it's important that you think about the appropriateness of the units, right? And when you think of those units, and we're going to look at some graphs, a couple of things that I want to talk about. Remember that you can have a line that goes up like this. What do we know about that line? That it's going up, it's linear, and that if it's going up, then the gradient is what sign? Positive, right? Okay, do you remember that? Well, a travel graph is going to be slightly different. It's going to have parts where they go up. It's going to have parts that are flat. It's going to have parts that go up slowly. Okay? And then it's also going to have an end. Why do you think it has an end? Well, it's not only the end of the graph, but when you're walking to school, eventually you stop, you get there, right? Okay? So we're going to look at that. Now, I want you to notice that when it's very steep like this, that means the gradient is very high, which means that you're traveling quickly. If it's flat, what do you think that means about when you're traveling? You're not moving at all. Say, for example, let's say I ran really fast to the bus stop, but now I have to wait all of this time for the bus to arrive, right? Then, when I get on the bus, it goes very slowly because there's a lot of traffic, right? So that's what a travel graph looks like. Now, do you think that all of this time, because remember, going across, you're measuring time, do you think that all of this time changes the distance that you travel? If it takes you 20 minutes, or let's say you live in the same house, right? Okay? And you go to the same school. And it takes you 20 minutes to walk to school, but it takes you 30 minutes to walk to school.
Oh, lazy.
Just because
just kidding.
She might have stopped to save a kitten at a tree or something. You never know. All right. So, but Guys, hold on. But does the time it takes them to walk there change the distance that they walked? No. So keep that in mind, right? There can be things, it may take you longer to travel the same distance. So the time doesn't affect the distance, right? Okay, so what we're going to do is we're going to go to our Education Perfect and we're going to look at a few of these, and you're going to be very happy with the fact that that we know most of this information. All right, here we go. So this penguin is on his way to work, and his movement can be displayed on a travel graph. So that's what we're going to look at is travel graphs. And again, like as we were talking about, you have time on the bottom, distance on the y-axis, and it's always given that. And they're sometimes called motion graphs because motion means that you're moving, right? So sometimes you'll see them as motion graphs. Remember that you have to have a title and you have to have labels, all right? And that time can be measured in seconds, minutes, hours, distance in meters, kilometers, right? So different units before more appropriate units. Okay? So, remember what we've done so far. We've been dealing with plotting, reading, and analyzing linear graphs. What makes a graph linear? We just mentioned it a while ago. It's a straight line, right? But travel very seldom works in a straight line. Because even if you're walking to school, do you always walk exactly the same speed the whole time?
Yes.
No way.
You're listening to a funky piece of
All right. Sometimes you go a little faster. Sometimes you might have to wait because there are people in front of you. Sometimes you might have to stop at a crosswalk, right? So there might be places used to stop. And we've also talked about the gradient. Gradient is how much line goes either up or what? Down. We've talked about the y-intercept. That's where the line crosses which axis? The y-axis. And we've talked about the equation of a line. And the general form of an equation is y equals mx plus c. Good. So one of the reasons we look at this is because it kind of gives us a good review of all the stuff that we've done so far. All right. Okay. Oops. So let's look at interpreting a graph. So here we go. We've got the bus traveling to school. This is Dave's trip to school. So you notice that it starts off at 0 because he started off going nowhere, right? He started off going nowhere, and he started off at the beginning. So that means that he's gone no kilometers, and no minutes. Then what do you notice between 2 and 4 minutes? The line goes what? It's really strongly up, right? The gradient is very strong, right? So that means he was going very fast. So
Sounds like a bad bus driver.
he probably hadn't gotten on the bus yet. He was probably running to get to the bus stop. Yeah? Yeah. Okay. Probably not.
We're not talking about a bus driver.
Okay. Well, all right. So he may have gotten on the bus there, and the bus just went very fast. Okay. And probably so in 6 kilometers. That's true. All right. Now, what do you notice next about that line? That after it goes very fast, then what? Oh, look at that. Same color. That's bizarre.
No, it is the bus driver.
Yeah, we're all doing bus. Yeah, it is the bus. So there, it's flat. What does that mean? Yeah, the bus is not moving at all, right? So what could make a bus not move? It could be at a traffic light, or it could be at a bus stop waiting for people to load. Or there could be traffic. Yeah, there could be something that stopped the traffic, you bet. And then notice that the bus goes again, right? It's at a fairly good speed. Then it speeds up again. And finally, it ends here, right? So how long did it take him for the whole trip? 24 minutes. And how far was the whole trip? 12 kilometers.
I'm actually worried about this bus driver, so
Yeah.
he only took 4 minutes to travel 6 kilometers.
Yes, he was zooming fast for there.
No. He did half of the whole trip in 4 minutes. And took them
And then the other half to do the rest
Yeah,
of
I'm a
it.
little
Okay.
bit worried about this bus driver.
Okay. Let's just read the graph and not be so judgy. Okay, here we go. They'll just make it a graph. Who knows? So it's not a real thing. Here's Rebecca's trip to school. How far did Rebecca travel all the way to school? 10 kilometers, right. So you see that the highest point represents the furthest point she went, right? And how long did it take her to travel that 10 kilometers? 12 minutes. Okay? How far had she gone in the first 2 minutes? 0. Look at that. That's flat for 2 minutes. Right? So she could have been waiting for her friend to get there so they could go. Lots of nothing. You never know. Then, it's very fast there, right? For the next 2 minutes, she traveled 6 kilometers. So probably she wasn't walking. She's probably sitting here in this flat area. She was probably waiting for the bus or somebody to pick her up and then traveling in a car, right? I know. They're zooming, aren't they? Then it's flat again. What does that mean? Stop and then continue on the journey. All right? So the travel graphs that you see are rarely going to be linear. Now, sometimes they could be linear. Say you're traveling along in a car at a constant speed. That would be linear, right? Very unlikely, but it could be linear. Good deal. All right. So again, they're just asking the same questions about her trip to school that I just did. The distance traveled. Okay? Look at him. How far did he travel to school? 9 kilometers, exactly. All right. And how long did it take him to go those 9 kilometers? Yeah, 120 minutes, 2 hours. So Clarence should probably find some other way to get to school because there's definitely something wrong going on there. Okay? There you go. All right? So, probably he should have gotten on the bus with Rebecca. All right? So, can you think you can read and plot a travel graph? Pretty darn easy, right? Good deal.